Okay, let's begin. Today we'll talk about using PHP to doing something else different, not web development, but scientific computation. We will work with toy examples because let's be realistic, PHP it's not like Python, but we can do some things. So, well, I'm Andreu. I'm working as a developer since 2010, and I'm currently working at Adsmurai, which is an marketing company. This isn't what I'm doing at my company, but I do it in my spare time, so I can devote as many time as I want. So, well, okay. Why we do that things? Because it's funny. In first time, I started that because sometimes we want to work on things that we don't touch in our daily day-to-day work, and because sometimes we want to experiment with what we can do with PHP or other technologies that we use. We want to try if something is possible, because it seems difficult, so we try it, and sometimes we succeed. There are more reasons, of course. If it were impossible, I didn't try it to begin with. So why? Because we can. PHP is a dynamically typed language. Dynamically typed languages are well suited for that type of things. PHP performance has been improving over time. The same is true for tooling. We have Composer and other practices, and we have a solid community behind that. So I think that we can do interesting things. There's a lot of things to do yet, but we have a good starting point. Well, there are more reasons. I'm envious. I have envy from other technology stacks like Python, Julia, MATLAB, or even C#. They all have a lot of tools that we lack in PHP. PHP is far behind from those technologies, so I think that it's interesting to work on that. There are more reasons, of course. I'll continue with that, but I think it's possible, and I think we should do that. Why? Because we need it. There are a lot of things that we can do with many scientific computational libraries. We can implement recommender systems, classification systems. We can do reinforcement learning, time series forecasting, or even natural language processing, or many other things that have business value. Recommender systems are very valuable for e-commerce, social applications, online assistants. We can implement fraud detection, language detection, sentiment analysis. We can perform automated A/B testing, or even doing modifications on the code at runtime to optimize our user interfaces, or even our algorithms using machine learning techniques. We can improve our reports implementing forecasting techniques. We can improve our planning or stock management algorithms. So we have a lot of things that we could do, but we aren't doing it. Or in other case, we are doing it with other technologies. So we have more complex stacks that require more skilled developers or larger teams that require sometimes a set of microservices communicating between them with IPC mechanisms or APIs over the wire. So if we are able to implement those things with one single language, we could keep a simpler stack that could be maintained by smaller teams with less skilled developers, so it will be cheaper. It's possible that for us that's not important, but there are a lot of people around the world. We are in high-income countries. That's not important for us, but there are a lot of countries where PHP is one of the main languages. We here have a plot from Stack Overflow's blog. We can see that PHP is used mainly by low-income countries. We can see some satellite projects like CodeIgniter, Laravel, or MySQL. It's not a satellite project, but it's very correlated with PHP. And we can see if we look in detail, technologies like MATLAB, NumPy, Pandas, Python that are used mainly in high-income countries. So if we are able to implement those algorithms, those technologies in PHP, we will be able to help those low-income countries to improve their technology. This is good by itself. This is a good goal. So I think it's interesting. That's one of my main goals. So I think that this is, for me, is the main reason, but it's possible that for other people this is not enough important. But for me, that's the case. So here we have another plot. We can see that PHP is more used in low-income countries, less used in high-income countries. We can see in purple how data engineering-related technologies are more used in high-income countries than in the rest of the world. And we can see that low-level technologies or systems-related technologies like Bash, C, Linux, or C++ are more used in high-income countries than in the rest of the world. That's because high-income countries can spend much more money into building blocks, while low-income countries have to use those building blocks, but they can spend the resources constructing or developing that sort of things. So if we improve this part of the PHP ecosystem, we could help a lot of people. So, where are we? To begin with, we should know what do we have, what we don't have. So, 2 years ago, a guy wrote an article, very interesting, talking about if PHP was usable to implement machine learning techniques. In 2015, it wasn't possible, or at least it wasn't possible in an efficient way. Why? Because there weren't toolkits, or at least there weren't enough powerful toolkits. About other topics, it was worse, because if we consider collaborative filtering, time series forecasting, natural language processing, I could find some efforts, but very dispersed. People who worked on that didn't do a great effort on the software engineering part. They did some experiments, some articles, but it was pretty. They were very simple experiments, so nothing that could be used in production or in business. Hopefully, that's not the case right now. We have something more. Here we have a very interesting project which is called PHP-ML. I don't remember the name of the developer because it's very strange. It's from Poland or something like that. It's difficult for me to pronounce that. So, why it's interesting? It's 1 year old, that project, at least. More or less. It's actively developed. It's well documented. we have a lot of available examples. It's pretty complete. We have many algorithms, classification algorithms. We have regression algorithms. We have data loading components for CSV, for XML, and other type of documents. I think that it has some drawbacks. Mainly that it's too big, at least for my taste. I think that it should be decomposed or split into smaller libraries in order to be cleaner, but also to help other people to implement other components using that subparts or that subcomponents of PHP-ML. Later we'll see some examples of PHP-ML. Let's continue with the list of things that we have, and then we'll see what we don't have. More things. That's a project that I've implemented. It lacks a lot of things, so I'm not very proud of it, but I think it's an important step, and there's a lot of work to do, and I think that it's worth it. It's easy to install. It works on Mac, on Linux, and Windows, but it lacks some things. We can plot, we can do plots or graphs. We can show HTML tables. And we don't have automatic or at least clean interfaces to handle composer dependencies. We have to require manually the autoloader, and we have to know in advance the absolute path of where we have those libraries installed. So it's easy to implement, but no one did it. I think I should do, because it's important. But well, that's the state of the things. So more things. That's another project that I started. Later I will talk about why I started that. PHP SDS, which is its name comes from scientific data structures. Was started after I discovered another project which is called PHP DS, which is an extension with polyfill that has the same features. This extension, PHP DS, is a very performant data structures collection that it's very interesting. But for our case, it wasn't enough, so I started to implement something different. The extension part isn't finished because I didn't finish the API. I have to experiment a little bit more. So we have two things implemented right now, which are tensor or ND arrays and matrix data structures. Tensor or ND arrays are multidimensional arrays that have many special features. We can reshape them. We can operate between them. We can operate on slices of those data structures. For example, we can pass a selector that specifies a subregion of the tensor and apply operations only over that subregion. And well, there are a lot of things, but I didn't document it, so I'm sorry. About the matrix, I was reviewing all the matrix implementations that are available in Packagist. All of them, without exception, are using naive algorithms, which are very, very slow, which are pretty bad election. My implementation is far faster than the other matrix implementations, and I didn't even use it smart algorithms. I only choose an internal implementation which is using a single contiguous array, instead of using nested arrays, like many other libraries are doing, and using a specific traversal order when we do multiplications. Only that, to take advantage of space and time locality. I think that many PHP developers don't usually think about performance, but in this case, that's very important, because when we do scientific computation, we do a lot of computations, so we need to do that in as few time as possible. So, for instance, we aren't using the Strassen algorithms nor anything more advanced like that, and I think that it could improve even more what I have done here. So I can pass this example because it's an experiment. It's my last experiment. It's not even finished. It's usable right now. We can forecast simple time series, but we only have exponential smoothing with damping trends and many other interesting goodies, but nothing really serious for production. So. This is another project that at the moment seemed interesting for me, and that was what stopped me to implement the data frame structure in the SDS. Archon is a data frames data structure, which is something that we can find in the pandas library for Python. And it's something that it should be, in fact, it's very useful when we deal with a lot of data or labeled data with some structure. The problem with Archon is that it's discontinued, and the election of its internal data structures and algorithms, it wasn't thought in order to be performant, so it only was thought in order to be easy to use. I think that someday someone should implement something better. Well, what we don't have? We don't have good data structures. As I said, I started to implement these two data structures, matrix and tensors. But it's an ongoing work. The main issue is documentation, because they are usable. Metrics maybe not so, because we don't have the inverse operator, but it could be used. But the arrays are completely usable. So that's one point. I have to state that performance is important. I'll repeat it again and again, because well, when you are working with thousands or tens of thousands of data points, and you have to try many algorithms or many combinations of parameters, you'll suffer from slow computations. So, what's more? Algebra utils. We have in PHP LAPACK. That's an extension that isn't available in most Linux distros. That's a problem, because if you want to use LAPACK, you should compile it, and if you lack this knowledge or time or systems rights in your server, you won't be able to use that. So I don't think that it's a good option. In addition, LAPACK's API isn't very good, and it can't work with contiguous arrays. It works with the typical nested arrays. So I think that we should implement those algebra utils in some other extension. So it's a lot of work to do. Okay, I'll repeat. We need performance. Here there are two things that we can do if we are PHP internal experts. We can choose better algorithms, and we can maybe work on native extensions. in the second case, we should know something more about PHP internals, but not so much as if we work with just-in-time compiler, or if we try to do geeky things like async I/O APIs or things like that. So, okay, that's an example. That's a graph that I plot many months ago that shows how choosing the right algorithm affects matrix multiplication performance. That's what I'm using in my current implementation, and and that line is what's being used in most PHP matrix libraries. So we have very, very, very faster implementation compared with what we can find in packages. But if you compare these times with Java implementations, C implementations, you'll want to cry, because PHP is very slow compared to other languages. More things that we don't have: visualization tools. Okay, we have plotting libraries and that sort of things, but we didn't integrate it with day-to-day working tools like Jupyter PHP. We'll see that in a few minutes. Like we can do in Python. If we work in Python, we have PyPlot and many other libraries, and while we are working on Jupyter, we can see plots or tables showing the results of what we are doing. This is something that we lack right now. So I think that if someone wants to work on that, I'll be very grateful. Okay, and what's more important for me, we need a working group, because there are a lot of efforts, but are very dispersed. We have the PHP ML. I've talked with Arkadiusz Kondas, now I remembered his name, about using PHP SDS in PHP ML, but there are some quirks that I have to polish before using that in PHP ML. But in fact, we are two guys working on that, but the guy who implemented Archon is another one that is working alone, and there are other guys or people working alone. It should be, I think it would be interesting if people interested on that meet together and talk about that and define standards and define APIs or interfaces, because this would improve our efforts. Okay, that's not the end. Okay, we have here, I have two examples. Let's begin with the boring one, and then we'll continue with the more interesting one. Okay. That's Jupyter. This is commonly used in the Python development world, at least in data-related tasks. This Jupyter notebook is using Jupyter PHP, which is a program that connects Jupyter with PHP and allows us to execute PHP here. So here is where I want to embed plots and graphs and other sort of things that currently I'm not able to do that. So okay, I'll show you the a tensor implementation, how it works, and the next example will be a PHP-ML implementation. Usage. Sorry. Okay, so I have to include the autoloader, manually specifying the complete path, because there are some things that that are missing. I import some libraries, some classes, and I start to use them. Okay. Here I'm creating a tensor filled with zeros, which has a shape. This tensor will have 3 dimensions. Every dimension will have a size. The first dimension will have 3 positions. The second dimension will have 8 positions, and so on. So this is like, if you can think about that, like 3 stacked 8 per 8 matrices. So for example, one example that could match this would be 3 images, grayscale images, 8 per 8 images. This could match this data structure. So we access concrete entries passing vector entry. This syntax is allowed in PHP. PHP Storm will complain about that because it's very uncommon and they think that it's incorrect, but it works. So we can pass anything as an index to our array-like structure. Okay. There are two examples of access. Here we have we are trying to access a position that doesn't exist. SDS will complain. That's what we should expect. We have many other static constructors: zeros, ones, constants. We even can construct random tensors following uniform distributions or normal distributions. If we use normal distributions, we can specify the mean and the variance. If we work with uniform distributions, we can specify the minimum value and the maximum one. This is nothing very fancy, but it's a building block that we'll need. So we have to begin at some point. There are many things that we could do. We can get the shape of our tensor. We can reshape our tensors. For example, before we had 3 per 8 per 8 tensor, and then we can reshape it to a 3 per 64 tensor. This is useful mainly for machine learning algorithms, where we transform an image that has some structure into an unstructured vector. The machine learning algorithm won't know anything about the sample structure, so we'll pass it a simple vector. So we'll need to reshape that. Okay. So here, after reshaping, we can see that we can access positions that didn't exist before. Nothing more than that. More things. We can apply many aggregation functions of our tensors. We can apply sums, means, variance, standard deviations. We can apply that operations to the whole data structure, but we can also choose what dimensions we want to collapse. So this is important because, for example, if we have we have an array of images and we want to compute the luminance. So we want a single number for sample. So choosing the concrete dimensions we want to collapse, it's useful, for example, in that case. We have here some examples of choosing what dimensions we collapse. Here we are collapsing the second and third I think I've lost one example I wanted to show. Well, that's not very important. Okay, that we can collapse dimensions following two ways. We can specify one by one if we want to collapse it or not, or we can specify one single collection specifying its concrete index. That's in that case. This would result as its result will be the same as that, because we are only collapsing the first dimension. Okay, so that's not very fancy. We can do permutations over our dimensions. This again can be useful if we are manipulating very strange data sets and that sort of things. We can slice our tensors. We can pass, for example, here here I passing a slice specification, and I'm assigning one tensor with shape 2, 2 to this part of the tensor that I've previously created. So we'll have, in this case, is a matrix, a 3x3 matrix. So we'll have 0, 0, 0, 0, 0, and 42, 42, 42, 42 in that case, because I only modified one slice, one region of the tensor. I used, in this case, a matrix, but we can do that with very complex data structures. Tensors, not. Okay, as you can imagine, we have binary operators, multiplication, addition, subtraction, and many others. We can apply, we can map functions over our tensors, and many other things. So this is what I'm working on in order to integrate it with PHP-ML. We'll jump to PHP-ML. That's more interesting. So here we have more things to talk about. To begin with, we'll import the classes we'll use. And as a second step, we'll load our data set. This data set, we'll see it in few seconds, but it's a list of phrases in English, Italian, French, and its language as a label after that. This example comes from the PHP-ML list of examples, but I've ported it to a Jupyter notebook, and I added comments in order to be able to talk about that here. So we import the data set, and after that we'll start to construct some objects that we'll use to classify our phrases and detect their languages. So to begin with, we'll instantiate a word tokenizer, so we'll transform our phrases into a list of words, and after that we'll pass this word tokenizer to a token count vectorizer. So this will transform our arrays of words into an array that counts the number of appearances of every word for phrase. In order to classify our phrases, we'll use another piece, which is the Tf-Idf Transformer. This uses a Tf-Idf algorithm, which comes from term frequency inverse document frequency. As I wrote here, the idea is that documents are characterized by their most frequent words. but words that are very common among the whole data set aren't as meaningful as words that are not so ubiquitous. So the Tf-Idf algorithm, which is commonly used in data retrieval usages, even if it has been substituted by better algorithms, it will be useful in this case to classify our phrases. So, in order to visualize our samples and to apply some transformations, we'll iterate over our data set. We can see here our phrases. Some ones are in English, there are another ones in French or other languages. So we apply two steps. We apply a fit step and a transform step. This transform step what it does is to transform our previous array of strings into an array of vectors. In this case, these are counters. This means that the first word, we don't know which is the first word, but the first word appears one single time in the first phrase, and so on. So here we have a very large array of arrays. After that, we apply the Tf-Idf Transformer. This gives us something more maybe strange. This is more difficult to interpret, but it's an index computed following that idea that I've told before. So this will be better in order to classify our phrases. So now we have data with we have prepared our data. So let's continue. We started with a data set that came from a CSV file, but we decomposed it. We extracted that into a simple PHP array. So we have to construct again another data set. So these samples array that we've been modifying in the previous steps, we'll pass that to that array dataset constructor, and we'll pass again the labels that we have in the original dataset, which are English, French, Italian, and so on. So when we have the dataset again, in order to train our classifier, we'll split the dataset into two main components, which are the training dataset and the test dataset. We split that because in order to evaluate the performance of our classifier, we need an independent dataset that it's not correlated with the dataset used for training. So we apply a randomized splitting. We tell to the splitter algorithm that we want 90% to the training dataset and the remaining part to the testing step. So well, we have a splitted data set, and now we construct a classifier, but this classifier isn't trained yet. So here the only thing that we are doing is choosing the algorithm. In this case is an algorithm based on super vector machines, and we are passing as a parameter the kernel. The kernel is a function that allows us to transform our vectorial space, which has some specified number of dimensions into a bigger vectorial space where we can find an hyperplane that separates the data points that belongs to one class or another class. So we perform that separation in the bigger vectorial space, and we return to the original vectorial space where our hyperplane won't be an hyperplane but an hypersurface, very curved. But okay, that's the general idea. So the RBF is one way of doing that transformations, but there are many other ones. So this is one possibility. And for our case, it's not very important because today almost every algorithm that we can choose will perform well for us, at least for the basic cases. So we'll train that. We pass the train samples and its labels. I don't especially like that API, but it's what it is, so it works. It's okay. And finally, we'll pass the test samples to the classifier to predict its labels. Here we have the labels. Maybe I should show to the samples, but well, if I finish that, and then we can analyze the test samples. And then we can measure the training performance, the classifier performance. In that case, we have a perfect accuracy. This isn't really realistic at all because I'm pretty sure that we have overfitted our training data set. This isn't too good. This is too good. This is unrealistic. Even with super classifiers developed at Google, these performances aren't realistic. So that's all. There are much more things about that topic, but I think that there are a lot of things to do yet. So if you have questions or something that doubts or Are you talking about why I am re-implementing things that exist in other languages? And
you mentioned the potential benefits of that.
Yes.
Mm-hmm. But don't you think that learning, apart from other things you mentioned, the popularity of PHP and the countries, but don't you think that learning more advanced technologies can be beneficial?
Yes, obviously.
Why to force staying on?
I don't want to force anything, but learning is an individual process, at least at this from this viewpoint. So everyone has to learn by themselves. You can collaborate, you can learn together with other people, but every people has to do that effort. While when you implement that, only a small team of people has to do that effort, and this effort will be shared with much more people. So this will never be at the level of what we can find at Python or Scala or R or Julia or that type of languages, but I think that it could be at the level that it would be usable for small business or small projects that that are conformed by people not enough skilled or without enough knowledge. So that's the aim of that initiative. I don't want to keep people blocked in one technology stack. I think that it's very good to explore another technologies. It's very good to learn. I don't think that people should stop doing that, but I think that we could help some people that maybe doesn't have money to pay university, maybe doesn't have time to learn things because they live in countries where they don't have laboral rights. There are many problems that you can face at your life if you don't live in wealthy countries. So we are not used to that problems, but they exist. So maybe we could help. Maybe not. Maybe I'm wrong. It's possible that I'm wrong, but I have some convincement about that. Yes.
In this regard, but what you have, what I think is a brilliant approach of teaching machine learning to people. If you could implement like the learning platform, I guess you won't make compete with those tools or with other people who know are broadly used in science. If you would use it as an approach, like anyone at science learned from your presentation regarding machine learning or refreshing information, therefore it would be very good because entry level the language and you can grasp the concepts.
Yes, but what you did see here, in fact, you can do it as well with Python, and I think that Python is. I'm defending doing it in PHP, but for a very particular reason. But Python is better suited for that purpose. So, if you live here in Germany or in Spain or in France or in UK, and you want to work on machine learning, for instance, maybe you should start with Python, and you won't have any problems because Python it's pretty easy to learn too. But the starting point is important because maybe you have passed 10 years working only with PHP because you don't have 18 years, but maybe you have 30 or 40, and you want to start with Python, and maybe at that point, being older, it will be harder to learn, and it would be harder to change the complete technology stack. So this notebook is available for Python, and in fact I copied it from the Python world. They invented it. This wasn't. This didn't start the PHP world. We are copying, and we don't. The PHP, at least at this moment, is not able to compete with Python at all. It's not able. It is impossible. At least right now. I don't know what will happen in some time, in many years in advance, but right now I only defend this approach because it could help people that is already working on web development and that sort of things. because if you are starting, my advice is choose Python. Don't choose PHP.
Thank you for the presentation. I think
Okay.
work is pretty brilliant. I don't know whether I missed this bit in your presentation. What is the principle that you use to build this? Is it genetic algorithms or neural networks?
No, in this case, we are using super vector classifier. Yes, which is you can think about if you think only in a two-dimensional space, and you imagine every sample as a point in the space. What this algorithm tries to do is to draw a line between one set of samples and the other set, and that line has one special property that it tries to be equidistant from the more extreme cases that are more near ones from one. Excuse me. For my pronunciation and my lack of vocabulary, this line tries to be exactly at the same distance from the nearest point from one side and the nearest point from the other side. So, if you think about it in 3 dimensions, what you have is a plane. And if you think of it in more dimensions, you have hyperplanes. But what we commonly find is that samples are mixed together, so we can draw hyperplanes or planes or lines that separate our samples. So there's an algebraic trick that transforms that space in a high-dimensional space that, in addition, sometimes introduces some non-linearities that cube that space. So, in that high-dimensional space, you are able to find that hyperplane that separates samples from one class and the other one. And then you return back to the previous original space, and that hyperplane becomes a cubed hyper surface. So maybe where you had a straight line, then you'll have a cubed line. But that cubed line in the hyperspace will be a straight one. This is a neat mathematical trick. It's very nice. It's very beautiful, but you have to spend some time to get it in deep. No. Super vector machines became trends before the deep learning advent. So super vector machines are very performant, are very fast, and they do very well. So this wasn't my choice. I based my example in another one, but I think that Arkadiusz Kondas, who implemented the first example, has more experience with super vector machines, and it's pretty expectable, that point, because people with experience on deep learning, there aren't so much, and in reality it's very trendy, but in fact most people don't know anything about that. They know that there are neural networks behind that, but they don't know why now we can train deep networks, and before we were unable. We have a lot of mathematical tricks that allow us to do that, but those tricks have been accumulated over years and years. If you go back to the 90s, the state of neural networks was was a disaster, because maybe you could, if you were very good at training neural networks, maybe you could stack 10 layers or 20. Now you can stack thousands of layers, so there is a very big difference. And over that time, when neural networks had those problems, supervector machines arise as a very promising alternative. So I think that the future is deep learning, but deep learning is more hard to apply, and it's you need better machines, you need more knowledge. So using supervector machines, it's a pretty good election.
Isn't it a bit complicated, for example, to use GPUs? Performance computation.
In order to use using GPUs here isn't possible, because to do that we need low-level bindings to bind PHP. Exactly, but no one did that effort for PHP, so we don't have this special piece that it would be very nice, it would be fantastic, but we don't have that piece. And in that case, we wouldn't notice the difference, because we had a very little data set. If we had a very large data set, maybe we could start noticing the difference between GPUs and CPUs. But in this particular case, it would be more complicated without any gains. Yes. So, more questions or doubts? Well, I'm using some components to do Bitcoin market predictions, but those algorithms are private, because one, are disaster. My algorithms are a disaster. If I have to share that, I would be ashamed. And second, when at the time when I if someday I obtain results, I won't share it, but because the money, not so. In any case, I won't share that. But yes, I'm using those components in order to predict Bitcoin market. But it's for particular uses, not for business ones. That's all? Yeah? Okay.